The last data structure that we're going to look at in Python, at least for this book, is tuples. So we have now strings that we can use, integers, floats, dictionaries, lists, and we're going to add to that tuples, which can be used in a variety of ways and to use some neat tricks on. Tuple is a lot like a list, but behaves a little bit differently. It is a list of values. They are ordered, so unlike a dictionary, they do have an order, and they're also immutable, which is different from a list. So lists are mutable, tuples are not, and that is probably one of the significant differences between the two, and we'll talk about what that word immutable means here in just a second. So I'm going to, again, like we've done in the past, go through a number of ways to define a tuple. One way is to just say, I want a tuple, and list out a bunch of things that you want to be in the tuple, and then we can print it. We can try to define a tuple with a single element, but if you do that, it turns out that to define a tuple with a single element, you have to follow it by a comma. Otherwise, it thinks up here that we just want this to be the string s, and we'll see that in just a second when we print out the values here, and we print out the type of tuple 1. And here's where we're going to get into the immutability versus mutability. With a list, you can say, hey, I want the first element in the list to be a Q. With a tuple, you can't do that. And it turns out to be useful to have an immutable version of a list, I guess, is one way to put it, because you can't have a list be a keyword for a dictionary. But you can have a tuple be a keyword for a dictionary. So you can't use a list because you can't have keys that change, and lists are mutable. Having repeated myself now many times. Another way to define a tuple is to just put parentheses around the list that you're making. So that looks a little bit like when we use tuples in math, and we talk about like the XY plane, and we give an ordered pair. You can think of that as a tuple. It might give a nice visual cue, so we can print out this tuple. You can do the same kind of slicing that we've done with lists and strings and such. So this should give us the second element in the list and the third element. It doesn't go up to the fourth one, which would be at index 3, because we always go to one less, right? So this should print out 2 things. And the third way to create a tuple is to start off with an empty tuple, kind of like we did with a dictionary, and then you can add stuff to it using the plus equals. We actually could have done this using lists and dictionaries, but I didn't go over that. So there's another neat trick for those other data structures. So I can add things to the tuple just using the plus equals. Might be also handy to do that kind of thing if you had to build up your tuple inside, say, a for loop. And then we still have the logical condition of testing whether something is in the tuple or not. Okay, so let's run this. And I got an error. So I got an error here on the immutability of tuples. You cannot do this operation. So I'm going to take that out, and we'll run this again. And okay, so we print tuple 1, and it just prints out as that list, actually with parentheses around it. And then we assign s to be tuple 1 and print out tuple 1 and then the type. And it turns out that if you just assign s like this, as I said before, that is of type string. But if we put a comma on the end, then it recognizes, oh, you don't want the string s, you want a tuple, and you want the first element in that tuple to be the string s. Okay, so that is of type tuple. And then here we're building up a second tuple using the parentheses. And that's there. And then we do the slicing trick, and we get the second and third element not needed. This is the empty tuple. And then we add an element, and now we have a tuple with one thing in it. Notice the comma after it. Just like we had up here. and then we add another element, and now we have a tuple with 2 elements, and then we ask is not in tuple 2, and that's up here, and it turns out that it is. So you can do that kind of conditional testing to see if something is in your tuple, just like you can do with a list or a dictionary. There are some neat uses for tuples. So we had talked about how to do a swap, and because we were basically creating a sort program in one of our activities, and when you want to swap 2 variables, then the way you do it is you set up a temp variable, set that equal to the first one, then set the first one equal to the second b, and then you come back and set b equal to the temp variable. It turns out that if you use tuples, you don't have to do that. You can do an assignment statement involving tuples because they are immutable. So I can set AB equal to BA, B comma A, and this will swap the variables. This side is evaluated first, and then you set this side equal to that, and this swaps the variables for you. So in Python, there's a very quick and easy, neat way to do swaps. Here's another neat trick. When you split a string like this, generally that would give you a list, and that list would have 2 things in it, hello and world, split on a blank in between. But you can make that equal to a tuple, and so it could have the H and W split, and H is going to be hello and W will be world. And a similar sort of trick, if you wanted to split up, if you had an input where somebody was putting in an email address and you wanted to check, is this a proper email address, and you could split this on the @ symbol. Look at the username that comes before the @ symbol. Look at the domain name that comes after the @ symbol. You could split that again on the period to make sure that there actually is a period in there. You could check to see if there is a period in domain name, that kind of thing. The neat thing here is that you can assign on the left-hand side, it looks like you're assigning this to 2 different things at once, but this is not 2 separate things. That's not the way to think about this. Think about username, comma, domain name as one thing. It's one tuple. Same thing up here with HW. That is one tuple, not 2 different variables, HW, and AB is one tuple. Okay, so let's run tricks with tuples. And we see that A and B are swapped. A start off as 1 and B is 3. And this swaps them to 3, 1. Then we print hello world.split, and you get that list, as I said before, with a hello world. But you can assign that again as a tuple and get the 2 words hello world and separately, which may be useful in some cases. And again, we do the split on the email address, and username turns out to be Billy Bob, and domain name is redneck.com. There's another neat trick that you can do, or could be useful trick with tuples. If you have a function that you want to return a value, well, what if you actually wanted to return more than one value? Then you can put those values together in a single tuple and return a tuple. So in this case, I'm taking a list of numbers, and what I want to do is figure out what's the largest or what's the smallest number in that list. Well, all the work is done, and we're going to have to go through this list one element at a time to find the minimum and max. And a simple way to do this is you start off with the very first element of the list, and you set that equal to the minimum or the maximum, whichever you're looking for. And then you just do a loop through the list, and you compare your current min and max with the value that you're at in the for loop. And if this value happens to be bigger than your current max, you swap and make the max equal to this new value. Or if this happens to be smaller than your current min, you swap that with a min. So all the work is in doing a for loop through this list. Now this only has 5 elements in it, so that's not very much work. But you can imagine a list that had, say, 1,000,000 entries in it. Then that's a lot of work for the for loop to do. So it may be a little more efficient to find the max and min at the same time. So we're going to do min-max. Min-max is going to return the minimum and the maximum elements in the list. So, I've got this backwards. I want the capital N to be the maximum. So it's going to return a value that is a tuple. And again, you think of that as not two variables there, but one single tuple. And that is part of the immutability of being a tuple, that you can go ahead and put a tuple on the left-hand side like that. That is not something that you could do with a list. All right, so we call min-max, and as I said, we set max and min to be the beginning values in the list. And this is a little bit inefficient because this is actually going to check the very first element in the list when I do the for I and L, but I was lazy when I wrote this for loop. And then we just check. So we're going to do a loop through all the elements in the list. So it's going to start here 1, or the first element in the list. Max and min are already that, so let's skip over that. And then we'll go to the next element in the list 3. And it checks, is max less than that? Well, max was set to 1 to begin with. So yes, max is less than that. So now we're going to make max equal to 3. Min, on the other hand, is not greater than 3. Min is still 1 at this point. So we go back up the list, we go to 0. And is max less than that? Well, max now is 3. So no, it's not less than 0, but min is 1, and min is greater than 0. So this is a new current min, so we set min equal to 0 now. This element in the list. Then we go to here, and max is just 3, is going to be less than 4, so we set max equal to 4. Min doesn't change, and then the last go through the list, min is 0, that is greater than -1, so we set min equal to -1. And so we should get a max of 4 and a min of -1. So this is just building on the theme here of the idea that we treat tuples as a single thing. It looks like we're using two variables, but we're using one. And because they are immutable, you can put them on the left-hand side of an equal sign, which can turn out to be useful in a lot of cases. So here we were able to return a tuple and set it equal to a tuple. Back here, we're able to do the trick with the swapping and setting this equal to a split command. So tuples have a lot of different uses, and we're going to see more of them as we get into more videos.